Ever wonder how all those memory theories fit together? We've seen different models. Some say memory is like a line, others say it's more of a workspace. Today, we'll mix these ideas into a bigger picture and peek at what the future holds. We've covered multi-store, which shows a flow from short-term to long-term storage. Then the working memory model, which says we have an active system with parts like the phonological loop and the visuospatial sketchpad. We looked at levels of processing. Deep thinking helps info stick. And Tulving's idea that we have separate memory types, episodic, semantic, and procedural. All these models shape our view of how we store and recall what we learn or experience. Most models agree on basics. We have to get information in, encoding, hold it, storage, and pull it out, retrieval. But the exact steps differ. Some focus on repetition, some on thinking deeper about meaning. Each model explains certain experiments well. For example, the multi-store model explains why rehearsal helps. The working memory model explains multitasking limits. But no single model covers all angles. Our minds are too complex for just one chart. Many experts now blend these ideas. They say memory has stages but can also be an active process. We keep building on older models to form richer ones. This lets us see memory not just as boxes but as a dynamic network. Which model made the most sense to you so far? Let me know in the comments. New brain imaging shows short-term and long-term areas often working at the same time. For instance, parts of the brain used in working memory can also help when we move info into long-term memory. It's more connected than we once thought. Here's a twist. Every time you recall a memory, you might slightly change it. Then you store it again. This process is called reconsolidation. That means memories aren't fixed like computer files. They can evolve each time we bring them up. This research can lead to new treatments for memory loss or PTSD, where recalling and adjusting the memory might help healing. It also helps in education. Knowing we can tweak memories might refine how we teach or revise. Teachers use spaced repetition and deep processing tasks to boost recall. Students who reflect deeply on ideas, connecting them to their own life, remember longer. Companies design training around the working memory capacity. That means shorter lessons, practice drills, and breaks so people don't overload. This helps employees learn faster and keep that knowledge for real tasks. Therapists might use memory techniques for anxiety, trauma, or depression. For instance, they guide patients to reframe stressful memories or to focus on certain details. Cognitive behavioral therapy often relies on the idea that changing how we store or recall events can improve mental health. We've taken a journey through models of memory, from simple input-output ideas to more dynamic and brain-based approaches. Research keeps moving and so does our understanding. If you want to boost your memory, try different methods: rehearsal, deep thinking, chunking info, and see what works best for you. Thanks for sticking with me through this series. Keep learning, keep asking questions, and watch how your mind grows. Memory science is still evolving and you can join the fun. Experiment on yourself, see how you learn best, and share your insights. After all, our models get better when we keep exploring.